In this video, I'm gonna talk about the surface energy and the surface tension. And probably you may have ever heard about surface energy and surface tension and whether they are the same. Here we want to prove that surface energy and surface tension are similar. So imagine that we have a rectangle, and in this rectangle in one edge we have a wire, and this wire is free to move in both sides, this direction or this direction, and we have a liquid film spread in this area whose area is equal to A. When we want to expand the area, we must pull this wire to the right side, and when we pull the wire to this direction, we have a resistant force against this movement. So we have to spend some energy to move this wire and expand the area. At first, we suppose that the energy of the system, which we show as G, is equal to G0 plus A multiplied by gamma. Gamma is surface energy. The unit of surface energy is energy per unit area, which is joule per square meter. And A is the area of this liquid film, as G is the energy of this liquid film, and G0 is the energy of this liquid film when when we don't consider the surface. In other words, it is the energy of the bulk of this liquid film. When we expand this surface, we pull this wire in a distance of differential x, and here we have a length that I show it as L. So the increase of the surface d differential A is equal to L multiplied by dx, and the amount of the force that we apply on this wire is F. The unit of F is force Newton per meter. So when we want to calculate the force applied on this wire, we should multiply this F by L. So this is the amount of force that we apply, and the amount of work that we consume to displace this wire equals to force multiplied by displacement, which is dx. So the amount of energy that we consume is equal to FL dx, which is equal to FdA. When we expand this liquid film by this distance, we increase the total energy by this amount, by dg, and dg is equal to A d gamma plus d gamma multiplied by dA multiplied by gamma. So we have two terms for differential of G. This and these are equal. So by equating equations 1 and 2, we have FdA equals to A d gamma plus dA multiplied by gamma. So we divide both sides by dA, so we have F equals to A multiplied by d gamma dA plus gamma. One thing that we should have in mind is that the dependency of the surface energy to the area in this case is 0. In other words, the surface energy, the amount of the surface energy is independent of the surface that we have, and this holds true for liquid films. So this term is 0, and therefore we have F is equal to gamma. So F is surface tension, and its unit is Newton per meter, and the gamma is surface energy, and its unit is Joule per square meter. And as you can see, the units in both sides are similar, the dimensions are similar. So the surface tension is equal to surface energy.